The recording process has also started. So just we will start with a couple of things. So before we get into the assignment and the working of some of the questions and all that, I'll start with a quick recap of some of the important points that we learned in the first lecture, while some students are still coming in. So as a recap of session 1 in vectors. So what are the various things that we learned in session 1? So first of all, we saw what were vectors, and we understood that they are physical quantities which have magnitude and direction, and which are defined by both the things, magnitude as well as direction. So to that end, we learned how to identify whether a given physical quantity is a vector or a scalar. Of course, we kept in mind that there's a third type of quantity also called tensors. But I told you we will talk about tensors at a later stage, okay? Because it's a little bit more complicated and we need to understand a few more things. So at the moment, whenever we look at a physical quantity, we will either classify it as a vector or a scalar. And how to understand which of the two to do, just think very calmly that whether the quantity has to be added by using laws of vector algebra or by using laws of scalar algebra. If you think you can add the two quantities related to, or two amounts related to the given quantity by just simple addition, like you do for scalars, like you do for volume, or you do for mass, or you do for time intervals, then you know it's a scalar quantity. Whereas you know that if you are going to use different properties of addition, like you do in the case of displacements or in the case of forces, then you know that you're dealing with vector quantities. So basically, that's how we identify quantities as vectors or scalars. I'm coming to the homework problem, people, be calm about it, okay? I'm seeing a lot of messages about specific questions in the homework exercise. I'll be discussing a lot of questions in the homework exercise, don't worry. Okay. So that was about what vectors was. Then the next thing we saw about was notation of vectors. So just a quick reminder of what kind of notation we use for vectors. So we saw that the specific notation was any alphabetical symbol with an arrow on top. This is read as a vector quantity. So the moment we put an arrow on top of an alphabetical symbol, we know that we are relating it with a vector quantity. Another important thing was that if we put a vector quantity in between two bars or in between the modulus sign, it means we are talking about the magnitude of the vector. We are talking about magnitude of vector E. So in short form, we might just say it is mod A, but in proper definition, or we might just refer to that quantity as just capital A without the vector symbol on top. So this is a short form, or saying that it is mod A is also a short form. But in principle, what does this mod sign on A vector mean? It means that we're talking about the magnitude of the vector. Yeah. And then we saw a couple of special types of vectors like unit vector, then null vector, etc. So these will keep coming along as we go along. We'll discuss about that. Then the next important thing, which was one of the most important things in the last lecture we discussed, was about representation of a vector. How do we represent a vector? That is, how do we represent a vector in such a way that it gives us information about both the things, the magnitude and direction. So we saw to that end, the first method of representation was called the geometrical method of representation. And that's what we've discussed till now. In the geometrical method, as we saw, a vector is notated by just drawing an arrow. So we relate it with a geometrical term rather than with an equation or with a set of words. And we let the arrow represent the vector itself. Wherein what happens is that if the vector is represented by the arrow, that means the magnitude of the vector E is directly proportional to the length of the arrow. Okay. And we saw that the direction of vector E, or what we call the line of action, that is a line along which the vector E is acting. If it is a force, it is acting along that line. If it is a displacement, it is precisely along that particular line. So that is called the line of application of the vector. So the line of application of, or the line of action of vector E is given by nothing but the direction of the arrowhead. Okay, whichever direction the arrowhead is pointing in, that becomes the direction in which the vector is acting, or more precisely what we call is the line of action of the vector. So this was about the geometrical method of vector addition. Okay. The geometrical method of vector representation. Next, we had got into vector operations. So we saw a couple of types of operations. And the first operation that we saw was in fact not addition, but was multiplication by a scalar. So we saw this kind of an operation, that if the vector B is equal to some scalar quantity into vector E. So if the vector B is defined as n multiplied by vector E, where the important thing is n is a scalar, which means that it could be just a number or it could be a quantity. But if it's a quantity, it's a scalar quantity. So example, n could just be 0.5, or it could just be -2. Okay. Or for example, n could be 5 kilograms, or it could be 2 milliliters. So in that case, it's a physical quantity, but it is a scalar physical quantity. So we saw to that end that when we multiply a vector like E with a number or with a scalar quantity n, then the resultant operation gives us another vector B. Okay? Such that what happens here is that the magnitude of the vector B becomes equal to mod of that number n. In case that number is negative, we have to remove the sign. So mod n multiplied by magnitude of that vector E. So for example, if n is 0.5, then the magnitude of B is half the magnitude of E. But if n is, for example, -0.5 also, even then the magnitude of B will only be half the magnitude of E. Magnitude will never come with a minus sign, hence the mod sign. Okay, and the direction of B, that depends on whether n is positive or negative. Okay, so and we also saw that if n is positive, then that means that B is along, or you can say parallel to vector E. Okay. Whereas if n is negative, then it implies that the vector B is becoming opposite in direction or anti-parallel. It's opposite to E, or what we call anti-parallel to E. Like that. All right, so we have still more people coming in, and it's a total of now close to 70 people in this book. Anyways, so let's continue ahead. So this was the first type of vector operation we saw, and this is pretty easy. Okay. Now the next type of vector operation was the addition of vectors, and this is where we left off last time. So this is the part that I'll be focusing on to begin with today. Okay. So we'll do a quick proper revision of all the things we've learned about vector addition, and then we will come to the homework problems. Okay. So what we had learned last time is sum or resultant of two vectors. So we want to find the resultant sum of two vectors A and B. Now suppose the vectors are given in geometrical form. So the vector A, for example, is suppose given to me like this. It need not be parallel to the x-axis. It could be anywhere. So this is the vector A given to me. And similarly, the vector B, suppose, is given to me as this one. So the vector B is separately given to me as, let's say, this one. So these two vectors are given to me. And then what I want to do is, now I want to find out, we want to find the resultant sum of A and B. How much that is, both in terms of magnitude as well as in terms of direction. So we saw that what we apply over here is called the triangle law of vector addition. So according to the triangle law of vector addition, what we have to do is we have to add the two vectors as if they are displacements, okay, by joining them head to tail from a common point. Okay. So what we'll do here to do the addition, suppose this is my starting point, and from here I'm making a displacement of A followed by a displacement of B. So this time what I'll do is I will just pick up this vector so that I don't have to draw it separately. So this vector is just picked up from here and placed from that point, from where I'm starting. So now this vector represents this only, because I have changed nothing about the vector. I've neither changed the magnitude nor the direction. It's still the arrow of same length and it's still pointing in the same direction. So when I simply lift that vector and place it somewhere else without changing the arrow in any way, that means I have not changed the direction or the magnitude. I'm still talking about the same vector. So I first place the vector A and then I pick up the vector B, but I place it below here now such that I am drawing it from the head of E. This. So now this represents my vector B. So my vector B now has come here. So this is the diagram which is ultimately now going to help me in finding out the sum of A and B. So from this diagram now, I will calculate the sum of A and B as this third vector which I'm drawing here in a different color. So the resultant sum of A and B will be this third side of the triangle. And hence that is called the triangle law of vector addition. So this side now, the triangle now represents a vector R, which is nothing but the resultant sum of A and B. So this was about the geometrical construction, how we use geometry to find out the resultant sum. Now further, if I know the magnitude of A, I know the magnitude of B, and I know the angle theta between A and B, then how will I find the magnitude of R and how will I find its direction? So that is where a statement of the triangle law comes in. And I'm not going to do the full derivation of the triangle law again here, but I'm just going to explain, quickly remind you what we did. So we saw that we carry on this line, okay, and then we drop a perpendicular from here. And in this figure, this is the angle theta we're talking about. This is the angle between A and B. Okay, so theta is the angle between the direction of vector A and the direction of vector B. So on that basis, then we apply trigonometry in this triangle. So if this side is X, this side is Y. We found out X and Y in terms of cos theta and sin theta. And then we found out the magnitude of the resultant in terms of X and Y and of course E. And doing that calculation, I'll just quickly remind you of what the resultant's magnitude became. It became root of A square plus B square plus 2AB cos theta. So there you can see. So the moment I know the value of magnitude of A, the magnitude of B, and the angle theta between them, I can always substitute them in the formula, and that will simply give me the third side of this triangle. In fact, in your maths trigonometry, you will study this particular law as what is called the cosine rule in a triangle. The cosine rule in a triangle tells you how to find the third side of a triangle, provided you know two sides and the angle between them. Okay. And the other thing is we wanted to find out this angle also, the angle that the resultant is making with respect to the vector E, because we also want to find the direction of the resultant. The resultant, after all, is a vector. So just finding the magnitude is not enough. We need to find its direction also. So to find its direction, now we saw we have the formula tan alpha is equal to B sin theta upon A plus B cos theta. Right. So this is the formula. This is the set of formulae which are collectively called the triangle law of vector addition. Okay. And from this stage onwards, I'm not going to bother so much about the derivation every time, because we've already seen that. We are going to be more concerned with the application of these principles to find out the sum and later the difference and things like that of vectors. Okay, so far this is what we've seen. Of course, we have just started with the discussion about triangle law. So we had seen it in a very limited framework where we are only discussing cases where theta was acute and things like that. So we will be doing a more sort of broad discussion of this today, including its application in some of the homework problems. But the first thing is again to just recall what the statement of triangle law was, and this was the particular principle. Yes. So I'm just getting some questions on chat about multiplication and things like that. So multiplication and things like that I'm going to come to very soon. We cannot multiply two vectors directly, but there is a certain operation called product. There's a certain operation called dot product, and there's a certain operation called cross product, and we will come to those very soon. And yeah, of course, over here, what capital A stands for is nothing but the magnitude of the vector B. And what capital B stands for is nothing but the magnitude of the vector B. And what theta stands for, I've already told you, is the angle between the two vectors. So this is the, first, you can say, important sort of formula that we have in vector algebra. It gives us the sum of two vectors, provided we know what all information. We know their individual magnitudes A and B, and we know the angle between the two vectors, that is theta. Okay. So now, once we are, sure about the revision of this and all that, now I'm going to come to some of the problems in the homework, and I'm going to show you how we use just these principles till now, which I have put up on the board till now, which are revision of what we did last time, how we use these principles to work it out. So I'm just referring to the exercise. So if you all can just go through the first problem in the exercise, I'll explain that. I'll start with the first problem, but I'll just give you a very short sort of hint or description of how to do the first problem. So just give me a moment. I'm coming to the exercise. Yeah, so coming to the worksheet, you will notice that the first problem was something about like this, that two vectors magnitudes were given. A and B's magnitudes were given as 3 and 4. And you had to find the condition in which the resultant was either 7, 1 or 5. Okay, so we had to find the condition. So I'll just state, so now I'm doing a quick run of the worksheet problems. So the first question was like this, that you are given that two vectors, let's say A and B, they have magnitudes of 3 and 4. And you have to find the condition such that their resultant, so this was the language used in the question, but you understand what is the meaning of resultant. The resultant is nothing but the vector sum of A and B. So their resultant R has a magnitude of either 7, 1 or 5. Okay, so this is basically the question, that mod R. Okay, so let's now understand this, how to solve this over here. So we want the condition that, let's take the first part, we want the resultant to be of magnitude 7. Okay, so one way we can solve it is we can think geometrically, that how would I arrange two arrows which are of length 3 and 4 so that their resultant is equal to 7. Now you notice that 3 and 4 sum itself is 7. So very logically you understand that in this case you would have to arrange A and B like this. You'd have to put the vector E, let's say like this, suppose it is, then the vector B must be exactly like this. It must be along the same direction. Only then the resultant can be 7. Okay, this is the only situation in which you can see that the resultant of A and B, now this is 4 in magnitude and this one is 3 in magnitude. This is the only situation in which the resultant of the two, which I can now, let's say, represent by this vector, will become 7. This vector will now become 7 only if the vectors A and B will become, okay. So A should be parallel to B. This is one way of understanding the problem just geometrically. Think of it like this, that I'm making two displacements of 3 and 4, but my resultant displacement, my net displacement should be 7. So then what can I say about the individual displacement? So obviously you understand they have to be in the same direction. Okay. Another approach to doing this is by algebra. Okay. So alternate approach of solving this would be by using algebra. Alternately, I can use the formula that resultant is equal to root of A square plus B square plus 2ab cos theta. And in this you see R is known, A is known, B is known, and what we have to find out is theta. So it is becoming an equation which is in a single variable, theta. So let's just solve this now. So the resultant we are given in the question is 7. The magnitudes of A and B are 3 and 4. So 3 square plus 4 square plus 2 into 3 into 4 into cos theta. So let's just solve this now. Okay? So to solve this, let's square both the sides. So 7 square is becoming 9 plus 16 plus 24 cos theta. So very interestingly, you see that cos theta will just become 49, okay, minus 25 divided by 24. When I just add up these two numbers, they are 25, this is 49, and cross multiply and all that. So that means cos theta is coming out to be 1. So you know the condition for cos theta to be 1 is that theta is 90 degrees. Theta is 0. This implies that theta is equal to 0. So that is again back to what we had done by geometry. Theta is 0 implies that A and B are parallel vectors. Okay, so this becomes another way of solving the same. So I'm just minimizing this for a moment so you can go through both the approaches I've taken. Okay, the geometrical approach was this one, and the algebraic approach of solving, or the formula based approach of solving, was the one below. So just take a moment to go through these two, and we will apply the same condition now on the second and third part of the question, or rather apply the same method on the second and third part of the question. So hope you guys are understanding this first part. Within my monitors are showing that I am audible over here, and the recording is also showing that. So could be a problem of connectivity at your end. So okay, don't worry about that. The recording will have the full audio in case you're not getting the audio clearly. I'm just checking my monitoring levels again, but yeah, so the audio appears all right from my side, which means it's okay in the recording. All right, now let's see the second part of the same question, where we want the resultant to be 1 instead of it to be this much. So in the second part of the question, we want the resultant to be 1. Okay. So this, if you now think logically, that you are making a displacement which is the sum of two displacements of 3 and 4. How can your resultant displacement be 1? And by just answering that question logically, you will come to the very simple conclusion that the only way that can happen is that if you take a U-turn, if you take an exactly 180-degree U-turn. So let us say this is my displacement of A, which is of magnitude 3. Now the only way you can make a further displacement of 4 such that your net displacement is equal to 1. The only way that can happen is if you take a U-turn and then make a displacement of 4. Any other way you do, if you go in this direction, or if you go in this direction, or any other such direction, your resultant will have to be greater than 1. You realize the only way your resultant can be 1 after making a second displacement of the same 4 is that if you do this, you come back like this now. So I'll just have to illustrate this by slightly lifting up this, but you understand that actually it's overlapping. So you have to do something like this. So your second displacement B over here is like this. So your second displacement B will have to be like this, and it will have to be of magnitude 4. So then you can see your net displacement is becoming how much? Your net displacement is actually becoming just 1. Because from where you started, you will end up at a position of, backwards of it. So that doesn't matter, but the magnitude will be 1 away from it. So B is of 4. Now in this diagram, you can see your resultant displacement will become this one. This small value from here to here, and this resultant will be equal to 1 in magnitude. So you can see here the condition for this to happen is that A and B are opposite vectors, or what we can call them as anti-parallel vectors. Okay. So that is the situation. Okay. Now let's look at the algebraic method also here. But that's going to be a little interesting. It will give us a very interesting result. So the alternate method is that you solve this, that resultant is root of A square plus B square plus 2AB cos theta. So I'm going to leave the substitution to you guys. You do all this, but I'll tell you the result you get. When you do all the substitution, you put R as 1, AB as 3 and 4, you will come to the conclusion that cos theta is equal to -1. Now this itself might come as a surprise to some of you people, that how can cos theta become -1? Because so far we have learned that cos theta only ranges between 0 and 1. So that is where today's lecture's second part will help us, because we will understand trigonometry in second quadrant, first and second quadrant. In fact, we learn in all four quadrants. If some of you are familiar with it, it is called the ASTC rule, or trigonometry in four quadrants. So we will understand very soon that this actually implies that theta is equal to 180 degrees, which further implies the same thing. Okay. So I'm going to come to the explanation of this very soon today, where we'll understand how to calculate cos theta for obtuse angles, and from that we'll understand cos 180 minus 1. Okay. So for the moment, you can stick to this method as a solution, just the geometrical method. And simultaneously, now I'm doing the third part, where we will understand that we want the resultant to be 5. Okay. So if I want the resultant to be 5, basically what I'm saying is that mod of A plus mod of B is equal to mod of R. Okay. Now A was 3, B was 4, and the resultant is 5. And common observation will show you that this is a Pythagorean triplet. It's a Pythagorean triplet, which means that actually 5 square happens to be 3 square plus 4 square. So when you think in terms of, yes, very good, it's a Pythagorean triplet. So when you think in terms of that, you realize your vector diagram is like this. A and B must be perpendicular to each other. That is the only way the resultant would be equal to 5. Okay. So this angle must be 90. This is 3. This is the vector A. This is of magnitude 4. This is the vector B. And in this diagram, in this case, if they are perpendicular to each other, you can see that the resultant would be the hypotenuse, which would be 5 in magnitude. So just common observation of this thing, that they are Pythagorean triplet, is showing you very fast, without doing any calculation, without any long substitution. They're showing you that the condition is that A is perpendicular to B. That is the condition for the magnitude of the resultant to be 5. Okay, so that becomes the answer to the third part. Now, of course, you can also substitute all this information in the triangle law formula. And in that case, when you substitute, you will get cos theta is 0, which will again show you the same thing. So alternately, you can go with that method also. So next up, I'll just quickly show you that method. So alternately, you substitute this. Now substituting here, you get 5 is equal to root of 3 square plus 4 square plus 24 cos theta. So when you solve this further, which you can do yourself, you will see that you will get cos theta as 0. And that will again show you that theta is equal to 90 degrees. It will again show you that this is the condition. Yeah, so whether you go by the algebraic method, which I have shown as the alternate method, or you go with the geometrical method, you are coming back to the same conclusion. Okay. So this, in a nutshell, was how to solve the first question. Okay. Now, second question I will leave to you to do, okay, which you will be able to do very well after today's lecture, and also applying the same kind of methods. Now let's come to the third question, which is also very similar. In the third question, so you will have these notes, don't worry, at the end of the lecture. So you can go to that. So third question is a very similar type of question. Third question is giving you basically information like this, that A and B have magnitudes of 12 and 5, and C has a magnitude of 13. Okay. And it is given to you that vector C is equal to vector A plus vector B. So now you have to find theta, that is the angle between A and B. So it's actually the same type of question as the first one, only the values, instead of 3, 4 and 5, the values are 12, 5 and 13. And you will notice that since, again, yes, I'm getting the correct answers, it's 90 degrees, correct all of you. Okay, since again you have 13 square happens to be 12 square plus 5 square. Because 13 square, you know, is 169, 12 square is 144, and 5 square is 25. So they are again a Pythagorean triplet. So that means again here what is happening? Theta is equal to 90 degrees. Or geometrically, your diagram should be looking like this. If this is the vector A of 12, and this is the vector B comparatively a bit smaller, but perpendicular of 5, then your resultant vector will have to be like this of 13. So in our particular case now, this is the vector C, which is A plus B, and its magnitude is 13, because the angle between A and B is 90, and their individual magnitudes are 5 and 20. So this is the complete solution. So I'm just minimizing this for a moment for you to just catch the whole thing, but very simple question, very much based on the first question. Alright, so this is the complete solution actually of the third question. You can also do this by the algebraic method using the root of a square plus b square formula, and you will get cos theta to be 0 again. Okay, now moving on. The fourth question. Now, fourth question is a question which is, I would say a little bit tricky, in the sense that it's a language-based question. The language has to be followed very carefully, and only then you can understand what the question is trying to say. And this is going to be a feature of many of our JEE level problems, that the question's language thoda sa twisted hota hai, and it's almost like a puzzle. The way the question is put to us in terms of the language of the statement, it is almost like they're talking in riddles, or they're talking as a puzzle, and you have to figure out what exactly they're trying to say. So let's try to make sense of this. So I'm reading out the fourth question. It says two forces of equal magnitude act at a point, and the square of their resultant is 3 times their product. Find the angle between them. Okay. So now, first of all, we have to try and understand what it says. Okay. So in the fourth question, we are talking about two forces, let's say F1 and F2, and they are of same magnitude that is given to us. So let us say that is x, that equal magnitude is x each. So what we are seeing so far is that mod F1 is equal to mod F2, or magnitude of force F1 is equal to magnitude of force F2, which is x. Okay. And it's also saying that, and their resultant, which is nothing but F1 plus F2, is such that its square, now what we mean by square of the resultant is square of the magnitude, is 3 times x square, because the product of their magnitude is x square. So this is the condition. The resultant is such that r square's magnitude, or r's magnitude whole square, is 3 times x magnitude whole square, or force's magnitude whole square. So from this we have to again find what the angle between the two forces is. Okay. So let's try and visualize this. So what this is saying is that if you were to visualize it just as a geometrical problem, let's say this is my first force, this is my second force. Now these two have to be identical in length, but obviously they need not be in the same direction. In fact, they are not in the same direction. So there is some unknown angle between them, which is my theta, which I have to find out. Okay. But the magnitude of this force is equal to the magnitude of this force, which is both x. Okay. This is my force F1, and this is my force F2. Now in the same diagram, where is my resultant? My resultant of the two forces is this third side of the triangle. And this time what will help us solve geometrically is that it's an isosceles triangle. So we will make use of the properties of isosceles triangle that we know. But also this statement now means that the magnitude of r is root 3 times x. So the third side is root 3x. So we'll make use of this. So from this, can we find the value of theta? And the answer to that is yes. We can find theta very nicely, because we can make use of a lovely property of isosceles triangle. And I'm coming to that property. Isosceles triangle has this property that this angle is equal to this angle, first of all, because these sides are equal, and their sum should be equal to the exterior opposite triangle. So alpha plus alpha, not only those two angles are equal, but their sum is equal to theta. So this is the first thing I'll use in my solution. Okay. And second property of isosceles triangle, which I'll use very effectively here, is this property that if I drop a perpendicular from the vertex of the adjacent to the equal sides, then it does what? It bisects the third side. Perpendicular from here, then this isosceles triangle has the property that this actually bisects this. So this should be equal to this. and you get two congruent triangles, two nice congruent triangles. Okay. So here in this you can see this will become how much? This will become r by 2. So this is becoming r by 2 as is this, and r is already given to us as root 3x. So now you can see that if you just concentrate on this triangle alone, you can see that in either of the two triangles, what is cos alpha? Cos alpha is base upon hypotenuse. Okay, so cos alpha being base upon hypotenuse, the base is how much? R by 2, and the hypotenuse is how much? X for each of them, you can see. So R by 2 is actually root 3 by 2x, and the hypotenuse is nothing but x. So you can see that cos alpha is root 3 by 2. So if cos alpha is root 3 by 2, what does that mean about alpha? It means that alpha is equal to 30 degrees. So what does that mean about theta now? Because theta is what we have to find out. So coming back to equation 1, so this is, let's say, equation 2 that we got. That cos alpha is root 3 by 2, that's giving this. So referring this back to equation 1, theta is becoming 60 degrees. So this is one way of solving the problem. This is the geometrical way of solving the problem. You can also use the formula based method, which I'll come to next. So in all these questions, I'll show you that we always have an option. Typically, we have an option of trying to solve the geometry of the vector triangle or trying to solve it as an algebraic problem using the formula of triangle law. Now, each of the methods is correct in its own right. There's no difference between them. Okay? But it's a matter of choice, and with experience, we'll also learn that in which problem which is going to be faster. In a certain problem, the number of steps in the geometrical method might be less. In a certain problem, the number of steps in the algebraic method might be less. So in an exam like IIT-JEE, that becomes important because you have to save time. Right now, for us, that is not so important. Time is not a big concern for us. In fact, what we should do right now is try and solve each and every question that we have with all the methods possible. Now, once you solve it by the geometrical method and you're comfortable with that, now next try and see that can I use algebra, or if you started with the algebraic method, you solve it, but then you come back to the geometric method and see whether you can yourself verify your answer by using that method, and that way you're comfortable with all the methods. So it's very important that you learn to experiment with all the methods you have, try to build your own unique solutions, take every problem like a challenge, okay, and try to challenge yourself and try to extend your knowledge to it. So I'm just leaving this for a moment. Now, if you have understood this, what you can what you can also try is the alternate method. If I did not use geometry to solve that triangle, if I just use the formula of triangle law, that formula, that resultant's magnitude is equal to, in this case, F1 square F1 F2, how would I get the angle theta? You can just try that also. I'll put up the alternate solution in just a moment, but in the meantime, you just try it out yourself also after you've noted this down. Make that triangle yourself. Make sure you understand the properties of the isosceles triangle. Okay. The properties of the isosceles triangle is, see, the two sides which are equal, x and x, the angles facing them, they become equal. So that's why those two angles, alpha and alpha, which are marked with red in the diagram, they are equal. They are equal because two sides are equal, x and x. Then the other property that we are using, that the sum of two interior angles in a triangle is equal to the exterior opposite angle. So if you take alpha and alpha as the two interior angles, the exterior opposite angle is which one? It's theta, which I marked with blue over there. So that is why I have the sum of alpha and alpha, that is 2 alpha is equal to theta. That's how I'm getting my first equation. So that is the first property of the isosceles triangle I'm using. Now the second property I'm using is where I've drawn that black line in the middle, where that line is perpendicular to the third side. So that property is, if you drop the perpendicular from the vertex to the third side, which is the unequal side, then it bisects that one. Okay. So if you drop a perpendicular from the vertex to the third side is the unequal one, the red colored one, then it will bisect that side. So that means that will bisect it into two triangles which are congruent, two right angle triangles which are congruent. So those triangles, now in that I'm using the property that cos alpha is based upon hypotenuse. So the base of that triangle is half of r, so it is r by 2 or root 3 by 2x, and the hypotenuse is of course x. And from that I'm getting alpha, and from that finally I'm getting theta as 2 alpha or 60 degrees. Alright, so this was about the geometrical way of solving this. I'll also quickly take you through the algebraic way of solving this question. And that is going to be something like this now. We are going to use the formula that R is going to be, in this case, is the vector sum of F1 and F2. So it's F1 square plus F2 square plus 2F1 F2 cos cos theta. Where theta is the angle between the two forces. Okay. So here it is given to me that F1 plus F2 is of course R, which is why I'm using that formula. And also given that magnitude of F1 is equal to magnitude of F2, which I have taken as X, and R is equal to root 3x. This was given to me in the question. The square of the resultant is 3 times the product. So that was this statement. That the resultant's magnitude is root 3 times X. So let's substitute this information there. So substitute this here, and we come to this now. So the left hand side is root 3x, and the right hand side becomes x square plus x square plus 2x square cos theta. So now just square both the sides, and so this becomes 3x square is equal to 2x square plus x square cos theta. So just solving this gives you the result you are looking for. That so 2x square cos theta. I'm mistaken. This is 2 here. So this gives you the result that cos theta is half, which you know is a condition for theta to be 60 degrees. So you always have this geometrical method to fall back on, this algebraic method to fall back on, in case geometry is not working for you. So in case you draw the triangle and for some reason nothing is striking you, triangle को कैसे solve करना है, क्या approach लेना है, you can always fall back on the formula method or the algebraic method. So this is this. Okay, so people, this was the 4th question. Now let us move on to the 5th question. 5th question is a very interesting question, and I'm just going to give you a hint over here. Okay, and I hope that many of you have actually discussed with me over WhatsApp over the last 2 or 3 days, and I'm happy to see many of you got the question correct. But some of you might not have attempted the question yet, so I'm leaving you with a hint, and with that hint, I'm pretty sure you'll be able to solve it. And otherwise, you can always discuss with me. So first of all, again, it's a language-based question. So let's understand the language of the question. Okay. So we have a carom board, and hopefully most of us have played carom, so we know what we're talking about. So we have a carom board which is, let us say, 4 feet by 4 feet. So look square now. And now in this carom board, so it is its dimensions are 4 feet by 4 feet. And let us say, just for reference, I'm also going to draw the perpendicular lines, the bisectors. Okay, so I'm just going to draw the other bisector, which more or less, to me at least, looks like this one. Okay, so let's say that's the center of the. So these are just guidelines. Okay. Now what is happening is my coin called the queen. So again, if in case anybody has not played carom here, just to tell you what the queen is, it's a red colored coin. Nothing extraordinary about it. Yeah, it gives you a lot of points and all that, but that doesn't matter for us right now. Now my queen is sitting at the center initially, and what we do is we hit a type of shot which is typically called a rebound shot. So in the rebound shot, what we do is we aim the coin, or we aim the the queen in this case, to hit the front at some point and then rebound from there and come in, get pocketed at the corner. So this is the path that we are looking for. So this is actually the path along which it should move. It should, as we hit the coin using a striker, so we aim with a striker somewhere here, it collides. So this should take this path. It should go in a straight line till it hits, let's say, some point P over here and rebounds from there and then gets collected in this. Okay, so let's do some further nomenclature in this. So suppose we are calling the corners as A, B, C, and D, and the center of the caramboid is the centroid G, and let's say this midpoint is also E. Okay. So what is happening is, in this case, we have to find out all these things. We have to find the vector GP. We have to find the vector PC. We have to find the displacement from the center to the front of the board, the displacement from the front of the board to the pocket on the side C. Now, all the sides have pockets, as you know. And we have to also find this thing. We have to find the final displacement, which is nothing but GC. So this is all what the question is asking for. It's asking us to find out all these things. Given that this is what happens, and given that the dimensions of the board are 4 by 4. So what we are going to use here? So this is where the question becomes interesting, and this is where there's a bit of hidden meaning in the question. Okay, we will have to assume here that the collision results in something like a mirror image reflection. Okay, so pay attention to what I'm saying. We'll have to assume that the collision results in a situation where at the point of incidence, that is the point P over here, if you drop a normal, then the angle of incidence should be equal to the angle of reflection. It should follow a mirror image kind of path. So this angle should be equal to this angle. Or in other words, you can also say that this angle, suppose it is some theta, that is equal to this angle, because these two angles are equal. So that is the small sort of hint that we will use, or small sort of assumption that we will use to solve the problem, that it rebounds in a mirror image kind of situation, like a light ray follows in the case of a plane reflection, that kind of thing. Okay. So with that, now see how we will use geometry. So we will use geometry in the sense that if you see now, the hint to solve this is that if you look at triangle GEP, that is this one, this triangle here. Just follow my cursor, this triangle, and the larger triangle on this side, that is this one. So this point below is C. So, and triangle PCB, these two triangles, they are similar triangles and they are right angle triangles. So they are similar right angled triangles. So use the properties of similar right angle triangles. You know that similar triangles have the ratio of the sides equal. So base upon base is equal to hypotenuse upon hypotenuse is equal to, you know, like that. So use that property, because this angle is 90 here and this angle is 90 here, and these two angles are equal. So these two angles are also equal. So they are what we call similar triangles. So their sides are in proportion. So you'll be able to use those properties. Okay, and yeah, understood. You won't be able to see carom the same way. But yeah, try not to think about the physics when you're playing carom, because you get distracted, and that way you might lose points and all, because you learn to play carom based on your hand-eye coordination, not based on physics. So keep it simple while you're playing. But yes, this is what is happening in this. Okay. So I will not put the answer up yet. Okay, I will give you the answer key by end of today, let's say. Okay, and by then you try to solve this question yourself. So this is the 5th question. Okay. So I'm just minimizing this a little bit so that you can get a clear picture of it. And meanwhile, I'll go back to the question paper and tell you what else I'll discuss. And go back to the exercise sheet. Okay, 6th question is again something more or less simple. Okay, if you just follow the language of the question and make a diagram, you will be able to get the answer. So I will leave the 6th question to you. 7th question also I'll give you a hint, okay, how to solve it. So next I'm coming to the 7th question. So in the 7th question we have this kind of a situation. It's given to us that there are two vectors of equal magnitude which are placed in a certain way in the xy plane. So first of all, let me draw the xy plane which is given to us in the question. So this is my x-axis, this is my y-axis, and this is my origin. Now my first vector E is given to me like this. It is making an angle of 30 degrees with the x-axis. So it's somewhere here. So the vector E is given to me, and this angle is 30 degrees, and this is the direction of it. Now my second vector is given in such a way that is making an angle of 120 degrees with E. So from here, I have to rotate by 120 degrees, which means that it would be in some kind of direction like this. And this is my vector B now. And this angle is given to me as 120 degrees. And further it is given to me, I think that the vectors A and B are of equal magnitude. Yeah, so I'll just read out the language of the question. So two vectors A and B have equal magnitude of 10 each. Okay, so this magnitude is equal to this magnitude, and they are equal to 10 each. And now we have to find the resultant C, which is the sum of these two. So as you can see in the diagram, the sum of these two will become this vector here. So we have to find the properties of this resultant. Okay. So this is the vector C, which is actually the sum of A and B, as you can see in the diagram. Okay. Now again, why I'm saying this question is easy for us, because it's like a little bit of extension of that property of isosceles triangle that we had seen earlier. So just apply that. These two sides are equal. That means these two angles are equal. So label them, let's say alpha each. Okay. Now the sum of so that's the first property. Isosceles triangle hai, to opposite wale jo angles hai of the equal sides, they will become equal. So I use that. Then the second property of any triangle, the sum of interior angles is equal to the exterior opposite. So you have alpha plus alpha should be equal to 120 degrees. So that means alpha should be equal to 60 degrees. So I have this. Now the moment alpha is 60, what about this angle now? You can see beta will also have to become 60 degrees, because of course 2 alpha plus beta is 180 degrees using that simple property. So this is now not only isosceles triangle, the triangle is actually equilateral. So there you are. Once you understood this is an equilateral triangle, the problem is completely solved. Because you know now this side will also be 10. So you found out the magnitude of C. It's 10. And you see that since alpha is 30 degrees, that means what is this angle? This is 90, 60 plus 30. So that means C is perpendicular to the x-axis. So in terms of the x-axis, this is the direction of C. So both the things come out solved like this. Okay. So it turns out that end of the day, this is a very easy question when you use the property of isosceles triangle like this. Okay. So that was about this. Okay. Eighth question is again something quite simple. I'll explain it to you. So you have to find the displacement of the tip of the minute hand. So just draw a diagram and you'll understand it very easily. Right, people, so hope this is clear up to this point. Just check on your messages for a moment before I continue. The side length of the carom board beta was 4 feet given to us in the question. It was supposed to be 4 feet. So I used that value in the diagram. Now when you go back to the diagram earlier, you will see that I have written on the side length is 4 feet, but that was given to us. Okay. Good. All right. So now I'm coming to the sort of hint for the 8th question. So hint for the 8th question is like this, that if you just visualize any standard sort of clock. So you have 12 here, you have 3 here, you have 15 here. This is the same thing as, and this is 30 or 6. In terms of minutes, this is 45, or in terms of hours, this is 9. And in terms of minutes, this point is 60 or 12. Okay, so that's what it looks like. Now the minute hand is, let's say, like this. This is suppose our minute hand. So when it's pointing to something, it's making a particular angle. So now you have to find out the displacement of the head of the minute hand, or the tip of the minute hand, as it goes from 15 past the hour to 30 past the hour. Okay, so I'll redraw the position of the minute hand initially. This is where it is. at 15 past the hour, and at 30 past the hour, it has come to this point. Okay. So the minute hand has moved from this point to this point. So the displacement of the tip of the minute hand is which one? Is this one. We just talk about the tip of the minute hand. It is displaced by this much. This is the displacement of the tip of the minute hand from x15 to x30. Now 15 minutes, some hour, that x could be anything, 1 o'clock, 2 o'clock, doesn't matter, to x and 30 minutes, that is the displacement. So this is my minute hand. And this point is the tip of the minute hand. So in this diagram, between this and this, the tip is displaced by like this. So you can see that this is equal to this, which is the length of the minute hand, and this angle is 90. So you can see magnitude of S is becoming L root 2. Whatever the length of the minute hand is, that into root 2. So the length of the minute hand is given to you in the question, and that's how you finally solve. So this is about the 8th question. As I told you, again, it's a very diagram-based question, very geometry-based question, very simple in that sense. Okay. Now we come to 9th question, which is our first really tricky type of question. Okay. So I'll just leave you with a second with this, and or leave you with a few seconds on this, and then if you have the question set, just read through the 9th question. I'll explain it in detail. Other part of question 8, okay, let me just check. So next half hour you can see. Now next half hour what is happening from 15 to 30, it's come here. Now next half hour it will go from 30 to 60. So kitne se ghum raha hai? 180 se ghum raha hai. So what will the displacement become? It will become like L plus L. You understanding? So in the next half an hour, the minute hand would have reached this position. It would have reached here. So if you're talking about the displacement from 30 to 60, then it's this. It's equal to 2L. But for example, if you're talking about the displacement from 15 to 60, then your displacement is in fact this side. It is again L root 2, like this. So, like that, the third part also, you just put it up. Okay. So now let's come to the 9th question. So again, 9th question, first of all, we have to understand the interpretation. Okay. Yeah, yes, well, then that's correct what you're saying. Okay, so I'll just explain to everybody. So first of all, it's saying that we have two vectors P and Q, and their vector sum is the vector R. So the first statement given was that just for any two arbitrary vectors P and Q, their vector resultant is equal to R. Okay. So what that means is that what the first statement basically means is R is the vector that we get when we just calculate the sum or the resultant of P and Q. That's very simple. Now the second statement is the one which is little tricky. Now it says that if we reverse the vector Q, it says that now on reversing the direction of Q, the resultant of this vector, which is minus Q with P, is given by S. So first of all, let us understand what we mean by reversing the vector. Okay. So it's talking about reverse the vector Q to get the vector minus Q. So basically minus Q, if you think about it that way, is the scalar number minus 1 multiplied by the vector Q. So that means mod of minus Q has the same value as mod of Q, which is equal to Q, but direction is opposite. Okay. So in very simple terms, if, for example, this is the vector Q, just by reference, okay, suppose the vector Q is just this, then in comparison, what is the vector minus Q? It will be this one. Just reverse its direction but keep its magnitude the same. You can draw it here if you like. You You can draw it here also if you like, it doesn't matter. You can draw it anywhere, but it has to have the same magnitude as this one. It has to be anti-parallel. So this is the vector minus. So this is the same in length as this. They are both of the same length q, but their directions are opposite. So that is what this statement means. That reverse the vector q to get the vector minus q. Now coming back to the question, what it is saying that the vector s is actually the sum of the vector p with the new vector minus q, which I got by reversing this. So this is the meaning of the second line of the statement. Okay? This is the meaning of that. Whereas the first line of the question meant this. Okay. Just take a moment to absorb this information. Now the question is further saying that we have to prove that or show that r square plus q square, r square plus s square is equal to twice of p square plus q square. It's a proof type of question. That means this vector's magnitude square, r vector's magnitude square plus this vector's magnitude square is equal to twice of p square plus q square. This is what we have to prove. Okay. Now, in case some of you might have learned ahead about what is vector subtraction, this is actually very easy. If you just use the vector subtraction formula, it's very easy. But I didn't want you to solve it by that method. I wanted you to solve it by using geometry. Okay. So let me see. Let me show you the method that I wanted you guys to use in this. Okay. So let's come to this. So all this information which I've written, I'm now going to convert it to geometry. That what is the information that p plus q is equal to r and p plus or minus q is equal to s. So let me make use of that. Okay. So now let's say the vector p is this one. This is suppose my vector p, and my vector s is supposing this one. And the angle between them, this angle is some theta. So my resultant of these two, as given in the question, is this vector. Okay. And I already know the formula which I've derived, that the resultant's magnitude is root of p square plus q square plus 2pq cos theta. This is the statement of the triangle. Now let's apply the same principle to the second one. So what's happening in the second one is that I have my same vector p as I had before in this diagram. So I have same vector p, but to that I am not adding the vector q. Instead, which vector I am adding? Minus of q. So sorry, it's not s over here. This was the vector q. So see, from p, the direction of q was like this. So if this was the continuation of the direction of p, q was along this line, which is at an angle theta. So minus q will be where? Minus q will be here. It will be opposite. So when I draw the vector minus q, which I am trying to add now, I'll have to draw it like this. This will be the vector minus q. It will be a vector which has the same magnitude as this vector here, this one. So this is also of length q, this is also of length q, but its direction is opposite. The vector q was along this direction, so the vector minus q is now opposite to that in this direction. So also by opposite angles, you'll see this angle is theta. Vector s, it is the sum of p and minus q. So the vector s is becoming nothing but this one. In this diagram, the vector s is this. So now for the vector r, I had a direct formula. I had the formula because it's like this. Okay. This is the triangle law formula. Now remember how we had derived the triangle law formula. We had actually dropped a perpendicular here. Okay. And then from that we had found out x and y. And then from that we had found out r was square root of p plus x ka whole square plus y square, in which we substituted x as q cos theta and y as q sin theta. This was the process that we used to derive this formula. Now we are going to use a very similar process to derive the formula for S. Now the resultant of P and minus Q, uska value kya hota hai? We are going to derive by using a very similar process. So first step is we'll drop a perpendicular here. Guys, I just have a glitch with my internet connection. I have to restart my modem. Just give me a minute. Okay, so we'll take a quick 2-minute break. Okay. So just take a quick 2-minute break. I will be back. Resuming the recording. Yeah, so coming back to this 9th question. So first of all, we understood from the language of the question. Just a minute, students. Okay. Just pause for a second. Okay, we just having some. Right. So hope you got a short break in between. So going back to that question now. So what we were seeing that it was given to us that if this is the vector P, and this is the vector Q, let's say. Okay, where the angle between P and Q, this angle here was theta. Now it was given to us that the vector S is actually P plus the vector of minus Q. So that means in our vector operation, what we have to do to find S is that we have to add the vector minus Q with P. Instead of adding the vector Q, we have to add the vector minus Q with P. Okay, so that's our vector operation that we have to do. So to find S, we first draw the vector P. That's fine. Okay. But then to that vector, instead of adding the vector Q, which was along this direction at an angle theta, we have to add the vector minus Q. So minus Q here, you will see, will become this vector. Will become this. This is the vector minus Q. Its magnitude is Q only, but its direction is opposite. So that's the key to solving this problem. That's the key to understanding this problem, that what we are adding here is not Q. Rather, what we are adding is minus Q. We are adding this vector. And so this angle here will also become theta. Okay. And now you can see that the vector that we are looking for, the sum of these two, is nothing but the vector S. So in this diagram, what is the vector S? It is the sum of this vector P and this vector which is minus Q. So that is this one over here. This one is the vector S. So we have to now do a derivation to find the magnitude of S, how much that is. Like we've done a derivation to find the magnitude of resultant of P and Q, like that we have to do. So follow the same steps. So from here, first of all, we drop a perpendicular. So in that perpendicular, if this side is now X and this side is now Y, okay, then this side is becoming how much? It is becoming P minus X. So once again, using trigonometry on this triangle which I'm shading, you can see that X is going to be Q cos theta, because X upon Q is nothing but cos of this angle, base upon hypotenuse. And similarly, Y is going to be Q sin theta, because sin theta is nothing but perpendicular upon hypotenuse, so it's Y upon Q. So accordingly, now what is on this triangle now, on this side, if you look at this triangle, so for this one now, you can see what is S? S is the hypotenuse. So S is becoming square root of the base, which is now, instead of P plus Q, it is P minus Q whole square plus Y square. All right, so that is becoming the resultant. So what I suggest you people do is try this out yourself. Okay, just give it a minute. Okay, and from this step onwards, find out the magnitude of S yourself. Try to find out the magnitude of S yourself and see if you can work out this question that way. Yeah, Dharmal, you've done it with another method. That's also okay. Okay, but in the meantime, I'm just trying to suggest that you try working this question out by this method. So just give it a minute, guys. Try to work out the magnitude of that S yourself. Okay. I'll explain how it works. Yes, correct. Yashovardhan, the answer you got is correct. Now you see, you use this value and compare it with the value of R square, and immediately you will see you'll get the answer. So you're on the right track. Now you got the value of S and you already knew the value of P. Okay. Now see if you can use that. So anybody else who's got the answer? Very good. Ashmi, that's correct. Manas, that's correct. Yes, very good. Okay, so hope you people are getting the answer using this now. Okay, so people, my whiteboard is on again. So once you do that, just completing those steps for you, you should be getting something like this. Your S was square root of p minus x the whole square plus y square. So it was square root of p minus q cos theta the whole square plus q sin theta the whole square. So just following all these steps further down, you will get this as, you will get s as, again using sin square theta plus cos square theta as 1 and all that, you will get this as p square plus q square minus 2pq cos theta. Okay, so you should be getting that. And then when you compare that with the value of r that you had, r was equal to root of p square plus q square plus 2pq cos theta. So again, immediately comparing equation 2 here, which I got by this with earlier equation 1, you can see that s square plus r square just becomes twice of p square plus q square. So that's the proof. Okay, so that is why this question was a little difficult, but because we had to do a bit of derivation here to find the relationship of s with cos theta. No, because in s we were adding p with the vector minus q, whereas earlier in r we were adding the vector p with q. So that becomes the solution. All right, people. So hope this 9th question is clear. 10th mein doubt hai dhruv? Okay, I'll explain. Now see, 10th question is actually again going to be that equilateral triangle wala question. So for 10th question, guys, what I suggest is just give it a reread. Okay. If the resultant of two vectors of equal magnitude 10 each is also 10, then find the angle between them. So just think in terms of what kind of a vector triangle you are getting. The two vectors you are adding, they are of equal magnitude. So let us say the vector c is equal to a plus b. And this the first thing that is given to you is that a is equal to b is equal to 10. And interestingly, c is also 10. So that means it is which type of triangle? It is an equilateral triangle. So let us make use of the equilateral triangle. But when I'm reporting the angle between the two vectors a and b, I have to be a little careful. Okay, so let's draw the triangle and understand what I'm talking about. So if this is a, then this has to be b, because the resultant of these two, let's say c, is this one. So in my vector diagram, this is the vector c, which is of magnitude 10, and these two here are the vectors a and b, which are also of magnitude 10. Now, can you tell me on chat what is the angle between a and b in this diagram? The triangle must be clear to all of you. But if I ask you theta, what is the angle between a and b? Now, just think twice and tell me, yeah. Aditya, you are correct. Yes. 120 degrees is the correct answer. Okay. Naman, you are also correct. Many of you are correct. Okay. So, angle between a and b, this is where you have to be careful. The angle between a and b is not 60. Because 60 is this angle. But which angle we want? We want the angle between a and b. So a ka direction kya hai? A wala direction. Okay. Whereas b ka direction kya hai? It is that one. So to switch from a's direction to b's direction, how much you have to turn by? You have to turn by 120 degrees, not by 60 degrees. See, this is the direction of a. So from here you have to switch by how much? You have to switch by 120 degrees. So your theta is in fact 120 degrees. So this is the answer to the 10th question. All right, so doesn't matter that, if you, in case you're wondering, we have taken a lot of time today in just discussing the assignment. But the idea was we had to learn new things through the assignment. The assignment was all about application of the triangle law. And last time we had just barely started with the introduction of triangle law. So part of this discussion is all about the application only. Now, before we move on to other laws, the second thing we have to see in triangle law is how to apply it when my theta is greater than 90. Now, what do I substitute cos theta when theta is greater than 90? Okay. Then Uday, I hope you will understand that the angle cannot be 90 here, because had the angle between A and B been 90, then the resultant would have been 10 root 2. It would not have been 10. This would have been a right angle triangle. I wanted to be an equilateral triangle, no? Because I want the magnitude of C also to be 10. So I'm forced to make the angle as 120. And yes, ASTC rule only we have to next see. So next, what we will understand as part of triangle law only, So applications of triangle law are next part. We'll see. So in this we'll understand what happens. What if theta is an obtuse angle? Okay, like 120 degrees or 135 degrees or anything like this, 150 degrees. So what do we substitute cos theta in that case? So through this we will learn what you might already know partly as the ASTC rule. So let me explain what the ASTC rule is. So first issue that I have over here is that if you think of trigonometric ratios, that is sine theta, cos theta and tan theta with reference to or with respect to a right angle triangle, that is what we've learned. They are defined as ratios in a right angle triangle. Then you will see that 120 doesn't make sense only, because I'm talking about a right angle triangle like this, let's say. So I'm talking about a right angle triangle like this, where this is the base, this is the perpendicular, and this is the hypotenuse. And I'm defining according to this cos theta as base upon hypotenuse, sine theta as perpendicular upon hypotenuse and all that. But now can theta be obtuse? No, it doesn't make sense only. Theta being obtuse doesn't make sense because the sum of the three angles in a triangle is 180 degrees. Okay. Achha, one slide above, I'm just going. Okay, so what we are discussing next, guys, is we are discussing this. Okay. Application of trigonometry or application of triangle law. What if theta is an obtuse angle? This is what we are discussing next. What do we do in this case when theta is something like this? So the answer to that is we apply ASTC rule. So let's understand ASTC rule next. So first of all, let us understand what we know of sine, cos, tan till date. आज तक हमने जो trigonometry में पढ़ा है, according to that, what is the meaning of sine theta, cos theta, and tan theta? It is in context of right angle triangle. Okay, till date, what we know about the trigonometric ratios sine, cos, and tan is nothing but in a right angle triangle, we define cos theta as base upon hypotenuse, sine theta as perpendicular upon hypotenuse, and tan theta as perpendicular upon base. But in a right angle triangle, is theta equal to obtuse possible? No, because the sum of the three angles is 180 degrees and one angle is already 90. So how can any other side be 180 degrees? Or how can any other angle be obtuse, like 120 degrees or 60 or anything like that? So we realize that this thing goes out of context when we are talking about a when we are talking about a non-right angle triangle. Okay, when we are talking about, okay. So next we have to understand the meaning of sine theta, cos theta in a different way. Okay, so this is where the new thing for us starts today, that we will learn sine theta and cos theta and tan theta not in terms of right angle triangle, but in terms of something called projections. So the meaning of the term sine theta, cos theta, and tan theta in terms of projections. Okay. And the moment we do this, you will understand that this thing makes sense to us. What we're trying to do now is calculate sine and cos of 120 degrees or 150 degrees. This will make sense the moment we do this. Okay. So we are trying to understand a new way of defining sine theta, cos theta, and tan theta. That is to a certain extent, it is about light, the projection of light on a circular system. So imagine we have a situation like this. Okay, now pay attention to what I'm saying. Imagine we have, first of all, we have to reference a coordinate frame. So we have a coordinate frame like this. Okay. In which what I've done is, of course, I've defined the coordinate frame like this. This is the origin, this is the x-axis, and this is the y-axis. So this is what we call the first quadrant, Q1. This is what we call the second quadrant, Q2, and similarly Q3 and Q4. So our coordinate frame, xy axis, or the xy system consists of these 4 quadrants. Okay. Now in this, first of all, what do I interpret as theta? So imagine I have just got a rod like this, and I have rotated it from the x-axis through an angle, anti-clockwise angle of theta. So this becomes my interpretation of angle theta. मैं ये rod को rotate कर रहा हूँ through some angle with respect to the x-axis, where our sign convention is that theta being positive means it is anti-clockwise. Theta is positive means it is anti-clockwise. Whereas if I say rotate the rod by minus 30 degrees, then it should have been over here. But if I say rotate the rod by 30 degrees or 60 degrees or 45 degrees, it would be somewhere in the first quadrant. If I say rotate the rod by 125 degrees or 130 degrees, you could see it would be somewhere in the second quadrant. So like that we define all the quadrants. Okay, so you can see the definition of Q1, the first quadrant, is that theta is between 0 and 90 degrees. The definition of my second quadrant is that theta is becoming greater than 90 degrees, but less than 180 degrees. So a rod rotated in the second quadrant would look something like this. Just as an example, if I am taking the case of theta equal to, let's say, 120 degrees. That would look something like this. So this is how we would interpret an angle which is greater than 90. This is, let's say, theta equal to 120 degrees. So it's in second quadrant. Okay. Now coming back to in the definition of quadrant system, what we mean by sine theta and cos theta. So let's come back to that. So sine theta and cos theta are defined as projections, okay, which is a very interesting thing over here. That now I'm coming back to the quadrant 1 situation where the rod is like this. Okay. Now what we'll do is we'll imagine the rod's length is 1 unit for whatever reason. Okay. We are defining the length of the rod as 1 centimeter or 1 meter or 1 inch or whatever, and this angle is theta. So that is the interpretation of theta. Now we define 2 new terms, and they are called the projections. They are called the projection, or in simple terms, you can also understand them as the shadow of the rod on the x-axis and y-axis. Okay. So if I drop a perpendicular from the tip of the rod onto the x-axis, then this thing that I've got over here, this is called the x projection of the rod. And similarly, if I drop a perpendicular of the rod onto the y-axis, then this shadow length which I've got, it's like if you throw light on the rod horizontally, it will throw a shadow on the y-axis. So that shadow is called the projection on the y-axis. Similarly, if you throw light vertically like this, it will throw a shadow on the x-axis, and that shadow is called the x projection. So in our term of definitions, the quantity x over here, it is called the projection. So this is a new term for us, projection of the rod's length, which by the way we have taken as unity on the x-axis. And similarly, y over here, this y is nothing but the projection of the same thing, the rod's length L on the y-axis. Okay. So these are the new terms we are defining now today. So I'll just minimize this for a moment and you take a note of this diagram because it's a little bit technical. Don't worry about the earlier 2 diagrams. They are simple. You will see that later. Just here you understand that theta का मतलब क्या हो गया? Theta is the angle by which I have rotated this rod of length L with respect to the x-axis. And I always use the same sign convention that anti-clockwise theta is positive and clockwise theta is negative. So suppose I have rotated by some angle theta like this. Now that rod is throwing some shadow on the x-axis. So that is called the x projection or the projection on the x-axis, this term. Similarly, it's throwing some shadow on the y-axis, and that is nothing but the y projection, or that is how this term is defined. Okay. So hope this point is clear to all of you. Okay, now we will see the relationship between x, y, and you'll see the relationship between x, y, and theta. So as you can see, just apply trigonometry over here. So x is the base. So x upon L, which is the hypotenuse, is nothing but cos theta. So you can see x is defined as L cos theta. And further, we have taken L as a single unit. It's a unit length. So what is, for a unit length rod, what is the x projection? It is nothing but cos theta. So this is what I meant by saying that we will now redefine sin theta, cos theta and tan theta, not in terms of right angle triangle, but in terms of projections. So what is the meaning of cos theta in terms of projection? You take a rod of unit length and keep it at an angle theta. So whatever shadow is throwing on the x-axis, that is nothing but cos theta. Similarly, whatever shadow is throwing on the y-axis, that becomes nothing but sin theta. So similarly, you can see y by L is equal to sin theta. So your y is nothing but L sin theta. And again, we are talking about a unit rod because it's a standard rod, so it's of unit length. So the y projection is nothing but sin theta. So this term becomes a new definition for us for sin theta. And similarly, this term here becomes the new definition for cos theta. And similarly, tan theta, we will see, will become a new definition and it will become y by x. So tan theta will be defined as y projection upon x projection. So tan theta is nothing but y by x. Or actually, in this statement here, I'll just define tan theta as the ratio of sin by cos. That will just make life a little simpler for us. So sin theta divided by cos theta जो भी होता है वो tan theta होता है. And now you can see sin theta is equal to y and cos theta is equal to x. So I'm just minimizing this a little bit. So this becomes the new definition of projection, or this becomes the new definition of sin cos tan in terms of projection. So don't worry about tan theta just now. Just concentrate on the sin theta and cos theta, how they are defined in terms of the shadow or the projection thrown by that rod on the x-axis and the y-axis. Okay. So once you're clear about this, I promise you people, you will never have difficulty with the ESTC rule or how to define sin theta, cos theta in second quadrant, third quadrant, etc. Today we'll discuss specifically about second quadrant, but in future also we'll see, we'll refer to all quadrants many times and this will become very easy to understand. Yes, Pratinab, I got your message. I will send you the recording of the first lecture. It's actually all there on a YouTube channel. So I'll send you the link of the YouTube channel. The earlier link I had sent on Zoom is not working anymore because it's out of space. What happens in Zoom, every 2 or 3 lectures, my space gets full. So I have to, but it's all there on the common channel on YouTube. So I'll send that to all of you people. Okay. Yeah, I'll send it on the group, don't worry. So all your lectures, PCM from the beginning, all the lectures are there on the YouTube channel. I'll send you the link of that channel today. Okay, people, so hope this is clear now. You understood the projection X and Y. So next, moving on to second quadrant. Okay, so now immediately you can see that by this method, now if I look at a situation where theta is obtuse. Okay. So I'm talking about second quadrant. Okay. So इसमें how will the diagram look now? The diagram will look like this. With respect to my XY frame, if I have rotated the rod by some obtuse angle with respect to the x-axis, this is how I define the angle now. The rod should be somewhere here. So this is the meaning of the angle becoming obtuse. Okay, and it has a unit length, remember. So it's 1 unit. Okay, so now let's talk about the projections again. So as you can see, the projection on the x-axis, when you drop this perpendicular, this is the projection on the x-axis. And this projection immediately you will realize is becoming negative. Now the x projection is negative, whereas the projection on the y-axis is positive. This projection is positive. You can see in second quadrant what is happening. The x projection is a negative quantity, whereas the y projection is a positive quantity because the shadow projected on the y-axis is on the positive side of the origin, but the shadow projected on the x-axis is on the negative side of the origin. It's on the x prime side. So that's why this becomes negative, this becomes positive. So accordingly, what happens? Cos theta, remember, was x from earlier. So that has become what kind of quantity? It's become negative. Whereas sin theta is positive. And tan theta is just the ratio of sine and cos. So tan theta will remain negative. That's how you have the S of the ASTC. Okay. So tan theta becomes negative. So that is why in second quadrant, the ASTC rule tells us that in first quadrant, all are positive. But in second quadrant, only sine is positive. Now that is the logic for this action. Because the projection on the x-axis becomes negative, whereas the projection on the y-axis becomes positive. Yeah, Dhruv, I will come to your question. Don't worry. People, so hope this is clear to all of you. Yeah, just keep your patient. Just be patient. I'll answer your question. Okay. Okay. So right now, this is the first important thing, that sine theta is positive in second quadrant, whereas cos theta is negative, and tan theta you don't need to worry about because it's always the ratio. You don't need to remember separately. So just remember this visual picture. कि जब मैं theta को 90 और 180 के बीच में ला रहा हूँ, my rod is lying like this. It is lying sandwiched between the x prime axis and the y axis. Is between the negative x axis and the positive y axis. So that is why the y projection will be positive, whereas the x projection will be negative. So immediately you understand that sin theta will be positive and cos theta will be negative. Now the next question is, ठीक है, मैंने ये तो निकाल लिया कि positive है और ये negative है, but what about the value? So next thing, let's understand how to calculate sin theta and cos theta for how to calculate the actual value. Sin theta and cos theta for theta being between 90 and 180. Okay, just hang on a second, guys. I have to switch on my battery. I mean, my battery is running out 180 degrees. Okay. Yeah, just note this down. Just a second. Okay. Right. So how do we actually calculate the value? So let's understand this with an example. Okay, then we'll come back to the general formula. So let's take an example of theta being, let's say, 120 degrees. So now I want to calculate cos 120 or sin 120, etc. I want to calculate all these things, tan 120. So how I do this? So again, it's back to understanding the diagram, that sin and cos are such that cos will become negative, sin will be positive. So in this diagram now, this is like this. 120 means it's somewhere like this. So if this angle is, for example, 120, then I can very easily find out this angle. Let's say alpha. So this angle alpha is what? It is 180 minus theta. And that in this particular case is becoming 60 degrees. Okay. So alpha is becoming 60 degrees. The length of this is, remember, unit. Okay. Now I have to do what? I have to drop the perpendiculars and find the projections. So if I drop the perpendicular here, this is the y projection. If I drop the perpendicular here, this is the x projection. So what I do for a moment is, instead of worrying about algebraic sign and all that, I just use simple trigonometry of right angle triangle. This is x, but this is on the negative side. And this whole length here is y, but it's on the positive side. So what I first do is I just worry about the magnitude of x and y. Forget about the direction. So I look at this triangle and I redraw this triangle outside. So when I redraw that triangle, it's like this. It's a simple right angle triangle where this is not y, because it's just a length. So I'm not worried about sine. There it was projection, so it had sine, but here is just a length, and this side is unity, 1 meter, whatever, and this angle is alpha. So you can see that mod y divided by L is sine theta. Okay, and mod x divided by L is how much? Cos theta. Okay, so I'm just zooming out a little so you can understand what I've done in this diagram. This is the key to understanding the value of sin theta and cos theta. Okay, तो मेरा theta अगर obtuse है, तो 180 minus theta will obviously become an acute angle. So for example, if theta is 120, then that angle alpha is becoming 60. So now if you just look at this triangle over here, this right angle triangle that you get when you're dropping the perpendicular on the x-axis, you're getting this right angle triangle here. That right angle triangle is very simple. It's a 60-degree angle right angle triangle where the hypotenuse is unity. Okay, so for that triangle, what will be the magnitude or what will be the side length of the perpendicular? It is mod y. And what is the what is the length of the base? It is nothing but mod x. So your regular trigonometry for right angle triangle, that is giving you ratio of perpendicular upon base is sin theta and ratio of base upon hypotenuse is cos theta. Okay. Sorry, ratio of perpendicular upon hypotenuse is sin and base upon hypotenuse is cos. And of course, L is equal to 1. So what is mod y becoming? It is becoming sin theta. Sorry, sin alpha. My mistake here. You should label these as alpha because the angle here is not that 120-degree angle. The angle is the 60-degree angle. So all these three angles, they are pertaining to the right angle triangle that I have drawn over here. So they are alpha. Okay. So what is y then? It is just plus of sin alpha. Because go back to your earlier diagram and you can see that y, the projection y was on which side? It was on the positive side. So I know magnitude of y is sin theta. So with the sin now y should become how much? It should become plus sin alpha. Similarly, from the second equation, I know mod x was equal to cos alpha because L is equal to 1. So what will x become now? Now what about the algebraic sign of x? So for that you go back to this diagram here and you see that in this diagram, what is the algebraic sign of x? It's on the negative side. It's on the negative side of the origin. This is the x-axis, this is the y-axis. So it's on the x prime side. So what's happening? I should replace the sign of x with a negative value and it's becoming minus cos alpha. So that is why we have that formula that cos of theta becomes minus cos alpha. Okay. So next you go back to what was the definition of x. Okay. The definition of x was nothing but cos theta, where theta was that obtuse angle, in this case cos 120 degrees. And what was the definition of y? It was sin theta. In this case it is sin 120 degrees. And from the diagram you're seeing what is the value of sin of y? It is nothing but plus sin 60. And what is the value of x? It is nothing but minus cos 60. So now comparing these two equations with these two equations, see what they are giving you. Equate x with x. So that means cos of 120 is how much? Minus cos 60. Whereas sin of 120 is how much? It is plus sin 60. Okay, so from this we get the general formula that therefore cos of theta is minus cos alpha. Or we can state this better, that cos of theta is minus cos of 180 minus theta, because that is what our alpha was. Our alpha was 180 minus theta. So that is why, so for example, what is cos 120? By this formula above, it is becoming minus of cos 180 minus 120. So it is becoming minus cos 60, which you know is minus half. So there you are. That is how we calculate the value of cos of an obtuse angle. It becomes minus half. Similarly, what is sin theta? That was the value of y above. So you can see above, y which was sin theta was becoming plus of sin alpha. So if we generalize this, we can say that sin theta is the same thing as plus of sin 180 minus theta. Whereas in the case of cos, the rule is different. There's a minus sign over here. But in the case of sin, there's a plus sign in between over here. So sin theta becomes this. So for example, now we can see that, for example, sin of 120 degrees is positive of sin 180 minus 120. So it is positive of sin 60. So that is why it is positive of root 3 by 2. So sin 120 is root 3 by 2, whereas cos 120 is minus half. So this is how we solve an example like this or an example like this. So I'll just reiterate the general formula before I take you back over here. So now in terms of formula, what do we know? Formula for second quadrant, it becomes like this, that cos of 180 minus theta or actually let's write it in terms of cos theta. So cos of theta is equal to minus of cos 180 degrees minus theta. So the minus sign is the important thing you have to remember, because in second quadrant cos is negative whereas sine is positive. So sine theta will become will become plus sine, because sine is positive, plus of sine 180 minus theta. This. And tan you can just remember by taking the ratio. So tan theta is just sine theta divided by cos theta. So sine theta is plus sine 180 minus theta, but cos theta is minus cos. So this will become minus tan 180 minus theta. So you can always think of the tan formula as an auxiliary formula. The first important two formulae are the sine and cos. So these become the formula for second quadrant. So this is what we can use to calculate cos or sine of any angle like 135, 120, 16, 150, etc. We use this set of formulas. So I'm just minimizing this for a moment to take you back to the whole logic of it. This is what we had done to begin with. To understand how to calculate, this was a topic over here, how to actually calculate. How to calculate the value of sine theta and cos theta when theta is greater than 90 but less than 180. For example, 120. So what we did is we took our rod, rotated it through 120 degrees, and we understood that the projection on the x-axis is negative, but the projection on the y-axis is positive. So I know that x is a negative quantity. I know that y is a positive quantity, but I just now want to calculate how much they are. So to calculate how much they are, I draw this special right angle triangle. The right angle triangle which I've shaded on the left for you. Okay. So I just make a diagram of that right angle triangle, and from that, just a second please. So just go through this diagram. I will get back to you with this. Yeah, people, so hope this explanation is fully clear. Okay. Right, so from this now, we get the value of mod x and mod y. Now, the sides of this triangle, they are mod x and mod y, and they are equal to nothing but sine alpha and cos alpha. Mod y is sine alpha and mod x is cos alpha, because remember the hypotenuse was unit length. Okay. So I know the magnitude of y and I know the magnitude of x. Now from my earlier diagram, I also know that the sine of y is positive, whereas the sine of x is negative, because the rod is lying between the negative x-axis and the positive y-axis. So x itself becomes how much? It becomes minus of cos alpha, and y itself becomes how much? It becomes plus of sine alpha. And then you know that by definition, what is y in terms of projection? In terms of projection, the y projection is always sine theta. And what is the x projection? It is always cos theta. So I'll replace y with what? I'll replace it with sine theta, and I'll replace x with what? I'll replace it with cos theta. So this is the definition actually. These two lines, they are the new definitions of sine theta and cos theta in terms of projection. So you replace x in this equation over here with cos theta. You replace y in this equation with sine theta. So you come to these equations. So you understand below here that cos theta actually becomes minus of cos alpha. Or in other words, cos 120 becomes minus of cos 60. And similarly, sine of theta becomes plus of sine alpha. So that is why sine of 120 becomes actually plus sine 60. Okay, people. So this is how we calculate the sine cos of this thing. Okay. Yeah, I know it is past 6 p.m. guys. Just another 2 minutes I will take. So quickly we will do a bit of practice with this, with just one small question. Okay. So this is the final formula which I have written for second quadrant. Now, just like we have developed formula for the second quadrant, at a later stage we will develop formula for third and fourth also. But for vectors right now, what we require is only the second quadrant. Okay, so we'll use these formulae from now on for second quadrant. So as an exercise problem now, quickly just work out for me. Find the values of these. Cos 135 degrees. Then sine 150 degrees. Then tan 120 degrees. And finally, cos of 127 degrees. This one. Yeah, be very careful about the signs. Anshuman, as you're solving, be careful about the signs. Yeah, now I'm beginning to get some correct answers. Okay, so yeah, Ashmi, you're correct. Dharmil, you are also correct about all three parts. Correct. No. And you can just use the value. For example, cos 45 is 1 by root 2. So from that you get. Okay. So it's nothing but substitution. You know? All you have to do here is substitution. So I will just quickly take you through the final answers, all of you. So, for example, in the first case, we wanted to calculate cos of 135 degrees. I think. This is what we wanted to find out. So we will just express it as minus of cos 180 minus 135. So that becomes minus cos 45. Okay, becomes minus cos 45. So that becomes minus 1 by root 2. Simple. So we are just using the formula that cos theta is minus cos of 180 minus theta for second quadrant. Okay. Similarly, our second question was sine of 150. So for that, we will use the formula for sine, which was like this. The formula for sine was that sine theta is positive, because in second quadrant sine is positive, of 180 minus theta. So this is 180 minus 150. So it is plus sine 30, which you know is half. So the value becomes plus half. Okay. Similarly, the third one, tan 120. This will become minus of tan of 180 minus 120. Yes, I'm getting the last part's answer also correct mostly. So minus tan 60. So this becomes minus root 3. Okay, so that becomes this. Now the last part is, most of you are getting it correct, but just to remind you all, this is related to a special triangle which I was telling you last time about. That special triangle is the 3-4-5 triangle. The 3-4-5 right angle triangle. So you can just, because it's a very common triangle in physics problems, okay, not so common in maths till now. But this 3-4-5 triangle, it has So if you take a right angle triangle of sides 4, 3 and 5, then this angle here, this angle happens to be 53 degrees. Okay. So this is just a special triangle to remember. Just like the 60, 30, 90 triangle, like that, the 53, 37, 90 triangle. So these sides. Okay. So from this you can see that sine 53, for example, is 4 by 5, whereas cos 53 is 3 by 5, and similarly tan 53 is 4 by 3. Okay, like that. So now if you notice the last question that I've given you, I've given the angle as 127 degrees. So what is 180 minus theta? That is actually 53 degrees. Okay. That's why sine of, or whatever it was, cos of, sine of theta will become minus positive sine 53, whereas cos theta will become minus cos 53. So sine of 127, which is I think what I had asked you in the first place. Sine of 127 will be plus 4 by 5, whereas cos of 127, if I ask you that, is minus 3 by 5. So these are the values. Okay. So correct. Okay. So this is about the complete explanation of trigonometry in the second quadrant. Okay. So now you have to start learning how to apply this in this formula. When we have this resultant formula, root of a square plus b square plus 2ab cos theta. Now you can see that the angle can also be obtuse. The angle between two vectors, if the two vectors are like this, then you can see the angle between them is acute. So in this case, theta is in the first quadrant. Okay. But if the two vectors are like this, like many of the questions we discussed today, but we did them indirectly through geometry. Now you can also do them by formula. So here you can see theta is obtuse. So it's in second quadrant. So you use these formulae for doing the vector addition. All right. So people, this is where we conclude today's lecture. And Dhruv, to answer your question. Okay. So before that, let me just talk about a little bit about the homework and stuff. So from today's lecture onwards, you will start also reading up and following from the module. And I will be giving you